Hi, so I was recently sent this multimeter to take a look at. Thought it might be vaguely interesting. Firstly, it's got Bluetooth, which is relatively unusual on multimeters, and also it's got a colour TFT display. Now this was from a company called PCE Instruments, who I'd not actually heard of before, but it looks like they do quite a wide range of sort of various lab instruments, and they also badge a number of multimeters from companies including Unity. This one actually did a bit of searching and found this looks like it's actually made by a company called CEL, and the actual original model numbers on a sticker on the back DT0989. And there's a few, I've seen a few very slight variants. For example, I've seen a version that's got a different colour insert and some very slight cosmetic differences. This is the PCE branded one. It's got branding on the window. The big thing about having a graphic display is obviously it has a huge impact on battery life. And so the question really is, does the graphic display give enough value to justify the fact that instead of having like hundreds of hours battery life, you've basically got to recharge this thing. I've measured the battery life on this. I did a rundown test. It was about 13 hours from a full charge. Pros and cons of this, obviously the fact it's rechargeable means you don't have to sort of buy batteries, but it does mean you've got to sort of keep it charged, and it depends a lot, for example, whether you're using it on the bench or in the field and so on. So for example, if you're in the middle of nowhere and suddenly find your batteries have died, on a conventional meeting you go out to a shop and buy some new batteries, whereas here you need to find some way to charge it and then wait for it to charge. Because the other issue with rechargeable batteries on a multimeter is that because the input terminals can potentially be at high voltage, you can't just have like a USB socket on the back, because anything connected to the internal circuitry is potentially live and hazardous. You could do it if you had like a proper isolated converter inside, but that would be relatively expensive. So what they do is they actually charge it using the low current range terminals. You stick it on this charge position and you sort of plug this adapter in, and this just has a sort of mains adapter that plugs into it. And obviously this adapter enforces it being in the switch being in the correct position, but obviously it means that you can't, safety wise, it means you can't plug this in and have high voltage connected to it, but also means you can't plug it in and be using it at the same time, because one of the other features of this, it does have some data logging facilities, but obviously the fact that you only have the battery life as your logging time, that puts an upper limit on how long you can do any data logging on. The supply for this is 10 volts, and I'll go into a bit later some more on that. There's nothing in here, so literally you can connect a 10 volt power supply to here. In principle you can connect 12 volts, but I think there's some internal heating issues that might be a problem with doing that. So, and generally it feels very nice. It's sort of rubberized all around. It feels really solid. There's no twisting at all. It feels really nice. The window feels quite solid. It's a super nice feel on the rotary switch. Startup time is fairly reasonable, a couple of seconds. One slight annoyance though is that when you switch between the current on this side and all the other ranges, there is a bit of a delay where it just blanks. Presumably it does a sort of brief power off as it passes through that range, which is just a little bit annoying. It's billed as an industrial meter. The PC website claims this is IP67, which means proof against immersion up to 1.5 meters. Now that is clearly not the case. The manual and the CEO website don't mention that, so I think that's probably an error in transcription. Although we've got these membrane switches, a fairly tight-fitting switch, just to show that it can't possibly be that waterproof. All you've got to do is look over the back cover, and you see there's no gasket, so it's just relying on this close-fitting plastic here, and in particular sort of down here, this cavity here. It's probably IP, and the overlap on here will give a little bit of protection against sort of the occasional splash and sort of light spray and rain. But the fact we've got this entry here means that it's just not going to handle any sort of actual immersion. So, and that probably gives it a realistic rating of perhaps IP64 at best. So I think they need to update that figure on the website before they get any units coming back under warranty full of water. One of the things that does show it being sort of more industrial orientated is it's got a 4 to 20 milliamp current range. This is quite a common thing used for industrial sensing and metering and so on. So you have a current loop passing 4 to 20 milliamps. The fact it's a current loop means the effective cable resistance doesn't affect the reading, but also the fact that the minimum is 4 means that if you get an open circuit cable, this is showing minus 25, which is the error condition. It does also have microamps going down to 0.01 microamp, and that's for AC and DC, and up to 10 amps. Then most of the other ranges are pretty much standard for most multimeters. So I did a few just quick quick accuracy checks, and accuracy seems fine. Not spectacular, but perfectly well within spec. Display response is pretty good speed wise. Obviously, one of the advantages of having the graphic displays, you've got this fairly high-res bar graph. Now, unlike a lot of meters where they tend to have like the whole bar graph for the whole range and a plus minus, this bar graph actually shows the sort of full plus minus range in one go. That's probably not too much of an issue because you've got the high-res display. The bar graph has much higher resolution than the bar graph on a static segment LCD. So, and I can see there might be some instances where that's actually useful to be able to see it swinging left right. The other nice thing is because of the graphic display, you can actually get all the graduations. So as it auto ranges, the actual bar graph auto ranges as well, which is quite nice. The lettering is quite small, but that's sort of fairly neat, so it's a nice feature. You've got frequency, that's up to 10 megahertz, but also it will do period and duty cycle. One thing I did notice is that it needs about a volt of input for the frequency range to make the frequency to make any measurement. And you've got the usual resistance sort of ranges. You've got diode test, you've got a continuity, not super quick. It does latch it to a minimum time, but it does. I'd guess maybe it's a couple hundred, up to a couple hundred milliseconds delay on that. So not horrible, but not ideal either. And it's got temperature. It comes with a this thermocouple adapter. There's no local cold junction compensation on there, so not super accurate, especially for the lower temperatures, but again, for a multimeter it's acceptable, I think. Now, the first obvious benefit from having the graphic display is that you can, firstly, you've got the various sort of setup options, which are a bit nicer to use than on a segment type meter, but also it has a graphics mode, so you can select the time base from 0.2 up to 10 seconds per division. So hit start, it shows you the current value, what range it's on. So that then just does a sort of chart plot of the voltage, and then that will go into like a roll scrolling mode. Once it hits the end, so you get like a sort of continuous chart recorder. So obviously that's something which might be useful in certain circumstances when you're looking at sort of trends and varying values. It auto ranges down and rescales the graph. Then you can actually save that to memory, and it saves it with the only reference is the time and date stamp. Then you can go back and actually look at the view graph, so you can actually view that, and you can scroll backwards and forwards through it. It's a slightly iffy problem with the display there. So that just gives you the date and time it was recorded. You don't really get much horizontal sort of timing information, which is... The other thing you can do is you can set up this recording mode where you can set a recording duration. Now, because you're limited to the battery life, in theory it goes up to days, but that's useless because you can't, short of applying some external power by sort of leaving the back off, you can't really make use of that. And you can set the sample interval down to sort of 1 second. And that will now record. It shows you how many samples there are. What it doesn't appear to be able to do is continue recording with the display off, which obviously would save quite a lot of power for longer recording times. It doesn't appear to be able to do that. So I can save that. I can actually show a graph of that. I can save that. I'm assuming that you can download this stuff over Bluetooth. I haven't actually got the Bluetooth stuff working yet, so but you can view it on screen. The other advantage of the display, you can show things like min-max, so this is showing min-max and average all at the same time, which could be quite useful. There's a few odds and ends in the setup menu, things like whether you want the beeper on or off, numeric format, which just tells you whether you want a dot or a comma as the decimal place. Some European countries like commas. Date format, you can have sort of sensible or stupid American month first date formats. You can set auto power up, you can either disable or set it from 5 minutes to 1 hour. The other thing you can do is you can set the display colours, so depending on your sort of preferences you might, there's quite a number of different permutations of display colours on there. Just sort of scroll through various options. It doesn't appear to do black on white though, but it will do quite a few, including some rather horrible permutations like sort of yellow on purple. I don't quite know why you'd ever want that, but you can have a yellow on purple display. And there's also a couple of different fonts. There's actually 3 options, but as far as I can tell, 2 of them actually look identical. So you've got this slightly sort of squarish font, which looks doesn't look particularly pleasant. Interesting, that only works on the main display. As soon as you go into the multi-display, it goes back to its seems to go back to its standard font. And the modes, there's a few additional modes, like for example in AC mode you've got frequency and voltage at the same time, which could be handy, for example, if you're setting up a generator. DC mode, you've got AC plus DC mode, millivolts, okay, it's AC and DC, millivolts. Frequency, again, you've just got frequency and period. Incidentally, one thing that's a bit annoying is you can't do graphs of frequency or temperature. Yeah, temperature is something you probably might actually want to do a chart of, but there's no graph option for temperature, which seems a rather stupid omission. Bluetooth, the only options here are on or off. Bluetooth, that adds about another 10 milliamps to the power consumption when you enable it. So obviously that's something you wouldn't want to leave on unless you actually needed it. And there's also info, which is actually built-in help, which is not particularly helpful. A few spelling mistakes in here, but don't quite know sort of what this F-no stuff is on the left, but doesn't really tell you anything that you couldn't figure out for yourself. So after some hassles getting the Bluetooth working, I got in contact with the supplier, and it turns out that the Bluetooth interface is BLE, so I actually needed to use this MeterBox IMM BLE software, not the standard Bluetooth stuff. So that wasn't mentioned anywhere in any documentation. This seems to offer some fairly basic functionality. So a meter appears on a scan. Presumably if you had multiple meters, they'd all appear here. That connects, and that's now just showing the reading. The update rate is fairly slow, but that may be as much to do with the Bluetooth BLE protocol. I'm not that familiar with BLE, but obviously it's aimed at low power, so it's probably not transmitting very frequently. So this does seem to offer fairly basic functionality. So for example, it doesn't appear to have any support for the dual display modes. It's just sort of sending out the basic readings. It does seem to track the current range selection. Well, interestingly, I can't see, it doesn't seem to want to work in frequency mode. But yeah, frequency mode, it just seems to totally ignore it. So as far as I can tell, I think this is a fairly generic multimeter application that isn't in any way really specific to this meter. So it clearly, it just isn't understanding certain of the modes that the meter can do. There's 1 or 2 meter modes that you can put it in. So for example, you can put it into min-max mode, but we're not seeing that on the display. It doesn't appear to be possible to actually get it out of that mode afterwards. And similarly, obviously there's a backlight control, which doesn't do anything on this meter. This hold function here, yeah, it puts the meter in hold, but I can't see any way of taking it out of hold again afterwards, so that's not very useful. This mode button doesn't seem to do anything as far as I can tell. Again, range, I can put it into manual range, select ranges, although there's no indication of the range on this display here. And again, there doesn't seem to be a way of taking it out of manual ranging mode. Record, that allows you just to record individual readings, and just whenever you press a button it just snapshots a reading, so that's not particularly useful. There doesn't seem to be any continuous logging mode as far as I can tell, and again I'm not sure how you're supposed to actually get out of that. Maybe save, okay, that's now saves it. So yeah, that's sort of not hugely useful. So sometimes the display is rather laggy. When it goes out of range, it does blank the display, it doesn't like freeze it. So you do know that the problem is that once it's out of range, you then need to reconnect. So the range I got, I think maybe about 40 or 50 meters away before it dropped out. Obviously that's going to be partly dependent on the phone. as to what the range is. So it's not, it's not the sort of thing you'd really use from one end of a building to the other. But I mean, I think if you want a slightly remote display from maybe the next room or the other side of the room, then it's probably okay. There is a graph mode, but there's no scaling on it at all. So I mean, this is just a total waste of time. I mean, you get this graph, but it doesn't even. It seems to, it's actually duplicating readings when it's not getting readings for the meter. There's no reading, so that's just a total waste of time, no use at all, and doesn't seem to be any way of downloading the data log. So yeah, I mean, the Bluetooth, it gives you a remote display, and that's really it. I mean, you can probably maybe reverse engineer the protocol to figure out if there's anything else you can do for remote control, but really, it's a remote display, and there really isn't anything else in there that's any use, as far as I can tell. There is one other thing which it does do, which, again, there might be some situations where it might be useful, is voice.
0.9890, 0.9890, 0.9890, 1.0793, 1.0700.
It's not updating on every reading, it's just updating regularly, and when it gets a reading,
0.8960, 0.8090, 0.8087, 0.8087.
again, it's a bit behind as well. Yeah, it's got ridiculous latency on that, so don't think that's particularly useful. Yeah, it looks like it's shut up. Shut up.
0.5159,
Okay. Yeah, it looks like it's probably buffering it. So it's assuming it's taking a reading once a second, throwing it into a speech buffer, and it's just getting behind itself. So, nice idea in practice, but just totally pretty much unusable implementation. Okay, let's take a look inside. Battery compartment's got a sort of half-turn lock thing on it. Cover comes off. Got battery, 10 amp fuse. There's an additional plastic cover over the low-range fuse. Presumably that's to meet IEC requirements. I can't think why else that would be. There's 4 screws holding it down, just self-tappers. And we see there's sort of very long flanges, which gives it its nice sort of rugged feel. This will also help with safety blast protection, so that if it does get a very high energy internally, that the fuse can't. The fuse ought to cope with it, but if it doesn't, it means that you've got this additional blast protection. So safety-wise, it looks reasonable. So inside, interestingly, we've got some sort of hard resin around these diodes, and they don't look like they've been particularly well put on. So I don't know if these have been replaced. I had a close look. The pad size looks about right for that diode, but I don't quite understand what's going on there. There are signs of parts being either reworked or replaced. Sort of quite a few of these diodes. The solder looks a different colour to elsewhere. There's also a bodge cap that's been added here, and the one next to it isn't particularly straight. The other thing is the battery contacts. The battery terminals are on this little subboard to get the height right. So I presume they're presumably using an off-the-shelf battery connector that didn't have the right height, so they've used this PCB to space it off. But in the process of soldering it down, they've actually got solder on one of the pins, which isn't great. That could potentially damage the connector in the battery. Unusually, you've got one of these CADC thick film resistor networks. That's something that you don't often see in lower end stuff. It's very common in higher end stuff like Fluke, but electronics wise it's fairly straightforward. We've got a Texas Instruments TM4C123, which is a Cortex M4 ARM processor, JTAG header there for programming, Bluetooth module, sounder up here, backup battery. There's some serial flash, which I'm guessing is for storage of images and data. There's an Intercell 12026 real-time clock here. Strangely, there's 2 crystals here. There's a 16 meg there, and there's another crystal there, but that isn't the real-time clock, because that's the real-time clock crystal. So, not quite sure what's going on there. Why would they have 2 crystals in here? Actually, 3. No, there's 3 crystals in here. We've got 4.9152. That's probably for the this is the Hycon HY3131 sort of multimeter chip, which is pretty very commonly used in multimeters. Various looks like maybe power management stuff down here. as an LM385 voltage reference, and what I presume down here is a temperature sensing thermistor. And this looks like the charging circuit. That's an EUP8057 lithium charge controller. According to the data sheet, that's got up to 15 volts input, so that's probably the upper limit of the charging supply. Current sensing resistor, and this will be the main regulating transistor, so it's presumably a linear current regulator. And it looks like there might be provision for adding some heat sinking. We've got this sort of this copper here. I wonder if maybe there's a potential for adding sort of solder down heatsink. Again, some sort of change of resistors here. You can see this is a 4-layer board. There's some of the trackings on inner layers. Got some isolation slots. Take that fuse cover out. You can see we've got reasonable isolation. 10 amp current shunt there. And the PCB layout on the 10 amp is not ideal. We've got a fairly long track with sort of 10 amps going through it. Hopefully that might be duplicated on the inner layers, but that's pretty thin. I mean, that's maybe about 4mm wide track. Incidentally, the manual does actually say don't use the 10 amp range for more than 30 seconds at a time. And also the fact you've got a 10 amp fuse on the 10 amp range, rather than say you often see sort of 12 and 15 amps. So sort of running this continuous at 10 amps or a minor over range, there's maybe a risk of blowing the fuse. It is a CEM fuse, assuming it's actually a genuine CEM fuse and not a Chinese copy, and that one is also CEM. Well, the print quality on that is not perfect, so I have no doubt that there are fake fuses floating around China. Whether these are genuine or not, I really don't know. And on the back there's a whole load of PTC protection devices. There's also what looks like a gas-filled sort of spark gap type device here, and a couple here. So it's got all the usual sort of protection devices that you'd expect to see. I think I noticed on the range switch there's a couple of sections where there's no solder resist on those sections here, which means that's going to potentially cause a bit of wear on the contacts. Obviously the surface of the PCB is a bit abrasive, and the display is just tab bonded down, sort of fairly standard construction method. One interesting detail on both on these holes and also the holes in the case is that some of the pillars have got an additional collar that actually goes through the PCB, so that accurately locates its position. It's not relying on the screw, and also it means that it does actually hold itself together before the screws goes in. So that's probably partly to help manufacturing, but also just make sure this is lined up nice and accurately. And there's no sign of any cold junction temperature sensing anywhere near the terminals, so the compensation is going to be assuming that the DMM is at the same temperature as the thermocouple plug. So it's not going to be super accurate, but if you want super accurate temperature, you're probably not going to use a multimeter to do that. And just to confirm that it is using that thermistor for cold junction compensation, if I just sort of spray a bit of freezer on it, you can see the temperatures values just shot down. So power consumption in off mode 1 microamp, which is insignificant. So you're not going to have this thing on the shelf for a couple of months and then suddenly find that the battery's gone flat. And in normal mode 65 milliamps, which corresponds to about 18 hours operation, if you believe the 1200 milliamp figure on the battery. I'll do a rundown test just to confirm what the realistic battery life is. And in auto power down mode 15 microamps, which is just fine, that's not a problem at all. And the battery indicator, first bar drops at 7.5 volts, next one 7.4, then 7.2, empty at 6.84. I'm guessing that may be fairly close to where the battery's internal cutout might start operating, assuming it's got one. And we keep going down to 6.7, 6.5. It's down to 6 volts, still showing no bars, and it still seems to be accurate. But again, this is going to be way below the dropout voltage of lithium cutout circuit. This is still going at 4.6, Okay, we're now starting to see some reference error. That's down at 4.25 volts. Now that means the power consumption isn't really changing. So that means they're actually basically pissing away quite a substantial part of the battery life. It's clearly, the circuitry is obviously designed to run on probably four AA's, or normally 6 volt supply. So by clearly using a linear regulator from the lithium battery, if they'd use a switching regulator, they could extract a lot more lifetime out of the battery, because if it's still drawing about 60 milliamps at 4.8 volts, if they use a switching regulator, that will go down to like about 40 milliamps at 7.2 volts. So they could be up to like probably almost double the battery life just by putting a switching regulator. So that's a bit of really sort of stupid penny pinching, where you've got the displays limiting your battery life, but they're just basically pissing away half their battery life for the sake of maybe sort of well under $1 worth of switching regulator for the main supply. So that's very disappointing. Okay, just out of interest, let's see how much of this power draw is down to the backlight. I'll just disconnected the backlight current limiting resistors and connected it to a resistance box. So if we turn the backlight off completely, 35 milliamps. So we've got about 25 milliamps out of that 60 odd as the backlight. That's what, about sort of 40% odd of the power draw is the backlight. It might be nice just to have some option to dim it down. There's no backlight brightness control. As it is, it's very bright. It's easily daylight readable, but it might be nice to at least have an option, if not necessarily full brightness control, just an option to dim it down, because we could dim it down to like sort of maybe there, and that's still perfectly readable, and that's reduced the power consumption by a quarter. So in situations where you didn't need a bright display but you wanted more battery life, that might be a useful option. Now I've done some quick experimentation with the charging. Charges through the milliamp connector, so it's going through the 800 milliamp fuse. On a flat battery it starts charging about 700 odd milliamps, and obviously that declines as it goes through the charge. The supply comes with is 10 volts. And because it's using a linear regulator, it doesn't really like charging at anything higher than that. At 12 volts, after a minute or so, the pass transistor had got up to about 120 degrees, so that's when I stopped. So, and because that transistor is not part of the charging chip, I think it's highly likely that transistor could get so hot it would just unsolder itself, because the normal thermal protection you'd have on an integrated chip isn't there. So if you're somewhere and you forget to take the charger, yes, you can charge it through the front, but only as long as you've got something that will give you 10 volts. It would have been nice if it would have accepted a much wider charge range than that, using a switching regulator, just so it could accept a decent voltage range and be more efficient. I would hope there's some protection against sort of high voltage, presumably the fuse plus PTCs, I would hope would actually protect it from damage. I suspect it might need to do that to pass the IEC safety test. If you sort of put it in the off charge position and connect mains across that, I would hope that the worst that happens is the fuse blows. But certainly, if you stick about, say, 12, 14 volts across that on a flat battery, I think there is quite a good chance that that charge pass transistor would either die or unsolder itself, just because it would just get too hot and there's really nothing to actively monitor that and shut it down. You can clearly see why they've done charging like this. Having to have something like this plugged in the front means that it bypasses that issue about having a charger on something which could potentially be connected to high voltage. So this is probably the simplest and cheapest way they could have done it, but it's not super elegant. If nothing else, it means you've got to cart this around with you. And there's a couple of other ways they could have done it. One actually quite elegant solution would have been to use like the key wireless charging standard, because that's reasonably standard. So that again gets around the problem of isolation, because that's inherently isolated, and those chargers are fairly readily available. So that would have actually been one quite nice solution, and also that would allow charging and operation at the same time, because the data logging is pretty much hindered by the fact that you cannot run this thing and charge it at the same time. The other method would be to have some sort of physical charge socket with an internal isolated converter. That would have some advantages. It means it could, for example, run on 5 volt USB supply. Because it's isolated, you could charge from below or above the nominal battery voltage. But obviously that would add some cost, but also on a product which is nominally at least sort of vaguely sealed, you'd have to figure out a way of sealing that connector. So I think, wireless charge would have been probably the ideal way of doing this. They decided not to do that and just go for the simple way, which is, it's the simplest and cheapest way. It's not really ideal for actual usability and usefulness. And the other way they could have improved it is, instead of having this, is to actually put a boost circuit in here, so you had a standard micro USB into here. So at least that would be one less mains adapter to have to cut around and potentially lose. So overall, it's an okay multimeter. Physically, it's sort of reasonably rugged. The display is super bright and super contrasty. There may be people that really like this. For example, maybe you've got a visual impairment that means you need a lot of brightness and contrast. This would be really excellent for that, because you do have this really nice contrast. It's quite good if you need to read it at a distance. The visibility of that is a little bit better than a conventional LCD with a backlight, although a lot of conventional multimeter LCDs are a little bit bigger, so that would make up for it. But certainly in difficult conditions where like the super brightness and contrast is a major benefit, then I think probably worth a serious look. The Bluetooth, unless they improve that app significantly, okay, it's a remote display, but the range is limited and most of the functionality is just barely there. It's a remote, it's really nothing more than a remote display. The charting, the Bluetooth is useless, the voice output is useless because the buffering, can't access the data log. So the Bluetooth side of it, I think, is not really, unless the app improves significantly, then I wouldn't recommend this as a Bluetooth meter. I've not really had experience of anything else that's out there, but I think they'd have to try hard to make it worse, to be honest. The internal graphing and data logging, again, that's something you may find useful. If that's something you have a use for, that might be a reason to consider it. There's hundreds and hundreds of multimeters out there, and everyone's got their own requirements. So, there may well be some applications where this is a really good fit. The data logging is potentially quite useful, but say the fact that you're limited by the battery life does put some limitations on it. You've still got potentially like 10 hours data log, so like a whole day's worth of data logging. So there may well be applications where that's useful. But say other than that, I think overall probably a little bit disappointing, particularly with the power management. For not much more money, they could have at least made the battery life quite substantially longer. And for example, by the combination of adding switch mode regulator and having the option to dim the backlight to preserve battery, they could easily have got over 24-hour battery life, maybe more than that. It's a shame they've just sort of cut that last corner. So build quality, physical build quality is reasonable. Internal quality is sort of okay, not perfect, but sort of it's okay. Probably something you'd only consider if there's, if you specifically wanted the nice display, or the things like the min-max on screen at the same time. If that's particularly useful to you, then maybe it's worth considering. But say as a general purpose meter, I think it's got probably too many issues to be worth seriously considering certainly not as your only multimeter. I think there are probably significantly better choices out there, unless you particularly need the nice high contrast display and the battery life isn't an issue for you. Okay, so as I don't have a particular use for this, and if you're still watching, then maybe you're actually interested and have an application for this, I'm going to give this meter away. To save hassle, I'm sorry, but this is only going to be available to UK and EU addresses. To win this, leave a comment in the comments as to why this specific meter would be useful to you. Now, this could be a genuine application, or it could just be something that's amusing or witty or something. I'll leave it till probably the end of the weekend, and I'll send you a message via YouTube messaging if you won this. So make sure that your email address is correct, so that you'll actually get YouTube messages. If I don't get a reply within 24 hours, I'll offer it to somebody else.
1.0841, 1.0841, 1.1638, 1.3568, 1.3208, 1.3084, 1.2804, 1.2785, 1.2345, 1.2345.